Okay, so I've got for this second question, y equal ax squared, something we've just done there. I'm just going to identify what x is and what y is. So substituting y equal 25 a times x squared is 5 square. So what's 5 square?
25.
25. So I've got 25 equal 25a. So what do you think a is going to be? What do we do to get rid of that 25?
Divide it by 5.
Divide by both sides?
What's it? Yeah, so 5.
To get rid of the 25, it's a time 25, so the opposite of timing is dividing, so divide by 25. So what's 25 divided by 25?
1.
There you go, so a equal 1.
Remember that this time.
So find the value of a equal 1. That means y equal x squared. This function is just y equal x squared. So that function would go through 1, 1, 2, 4, 3, 9, 4, 16, 5, 25. So it's just like a machine to square. And if you've got a negative 1, you'll have positive 1. Negative 2, you'll have a 4. Negative 3 will be a positive 9, etc. Okay? My tablet seems to be not playing ball game just now. Might have to send it back.
We kept the receipt.
Okay, so let's have a look what we're looking at today. The basic properties of a quadratic function. So we've looked at them a wee bit when a is positive. So that's what we're going to look into this function in this lesson here. Know the properties. So we've looked at turning point, we've looked at intercept. So it's very much similar to that. And we're going to look at linking a y equal x squared graph to y equal a times x minus b squared plus c. And that's what we call the completing form. So every quadratic can be written in this form, a times x minus b squared plus c. To do that, here, as you can remember, I told you about, you've got a symmetry in your parabola where x equal b. I've got b and c here because when x equal b, b minus b is 0, and c is your turning point. So BC is your turning point, and the y-intercept would just be when x equals 0. Sorry. Yeah, x equals 0. That would be a squared b squared plus c if you were to put that completely. So we've said these are parabolas, axis of symmetry, turning point at BC cuts. We've got a minimum turning point when a is positive. That's what we mentioned there, because everything is above that minimum value, and we've got a maximum turning point when it's the opposite side. So usually you hear people saying you've got a happy face when a is positive, and when a is negative, you've got a sad face. Yeah. So if you want to think about it that way, when you're negative, sad, when you're positive, you're happy. So now let's see if we're asked to sketch this graph, x minus 3 squared plus 2. So properties, what we need to find is, in order to sketch this, a few things. Axis of symmetry, when x minus 3 equals 0 or x equals 3. So that'll be, I'm just going to put them on that side here. So x equals 3 Oof. This is struggling. It's not me. And then what we said, turning points when x equals 3, y equal 2. So 3, 2 would be my turning points. What else? When x equals 0, I'm going to find what we call intercept. So -3 times -3 is 9. 9 plus 2 is 11. So I've got quite a few points. I've got minimum turning point here. And I've got an y-intercept here. So let's see how we go about that. So a equal 1, positive, happy face. B equal 3, and C equal 2. 3, 2. Turning point is BC, 3, 2. You just put your point. Axis of symmetry, B equals 3, or what we call x equals 3, going through there. When x equals 0, I've got 11, so you put that there. So if you were to draw this, you would say, okay, I've got 3 here, so technically I should get 1, 2, 3. So because it's an axis of symmetry, I should just draw my parabola going through that point too. So it'd be looking like going down, hitting the turning point and back up again. Okay, so that's how you would draw your parabola. I was not too bad, quite close. So second example here, example 2. Let's say they've asked us to sketch x plus 2 square plus 1. Again, we're going to use same approach. First of all, we've got a happy face. Second, b equal -2. And when we've got x equal -2, y equal 1. So turning point -2, 1. Axis of symmetry -2. And when y equals 0, sorry, when x equals 0, I've got 2 squared, that's 4, plus 1, 5. So 0, 5. So I've got 2 points. I'm going to try and make another point just to help me. And hopefully you can draw your parabola through this. And that's how you would draw, sketch the graph of y equal x plus 2 square plus 1. Okay, so bit of practice. So this time, instead of us having to draw the sketching it, we've been told that write down equation of this curve. So what you would look for is, remember what we said, when x equal -3, I've got y equal 5. That's my turning point. So that means I'm going to have something in the form of x plus 3 square. So if you were to complete the square, x plus 3 square plus 5. That's us. That's all we needed to write down equation of this curve. So since a is positive, we've got minimum turning point, b equal -3, c equal 5, x plus 3 square plus 5. Yeah? So completing the square is quite powerful because you only need 1 point, that turning point, to give you the equation of the line. So here I've got a 3 minus 4 with a equal 1, b equals 3, c equal -4. Write down the equation just based on that 1 point. As simple as that. X minus 3 square minus 4. And if they ask you what is the axis of symmetry, you just say x equals 3. That could be another added question for a 1 point bonus. A different example. I've got b equal -4, so that becomes x plus 4 plus 5. So x plus 4 square plus 5 is the equation written in completing the square. And this is a past paper question. The equation of the parabola in the above diagram is x minus 3 square minus 4. So I know, looking at this, coordinate of the minimum turning point is when x equals 3. Oops. When x equals 3, I've got y equal -4, because 3 minus 3 is 0. So states the coordinate of the minimum turning point, you just write here 3, -4. Okay. State the equation of the axis of symmetry. So we just said here, this is your axis of symmetry. It goes through there. So it goes through x equals 3. So you just write x equals 3. Okay. And now A is the point 1, 0. So I've got here 1, 0 for A. So y is 0. So for B, you're going to have y equals 0 as well, because these are what we call the x-intercept, remember? So those 2 points are what we call the roots. It's where this parabola cuts my x-axis. I've got 1, 0. What you could do is from 1 to 3, how many steps do you have? 1, 2. So that'd be 2. That'd be 3. Because you've got a symmetry here, you've got the same amount of steps from 3 to 4, and then 4 to 5. So basically, here is the point 5. So you can do it that way. You will get the mark, and you just say 5, 0. States the coordinate of B, 5, 0, by just looking at the symmetry. Okay? That's quite easy. That's quite quick to do. Some people might say, oh, I need to find the roots. If you want to, the only thing is you need to then explode that by saying that this is x squared minus 6x plus 9 minus 4, and do the factorizing. So let's say you can't see that there's a symmetry here. You would just rewrite this as x squared. So that's another way of doing it. You would say this is x squared. So we said minus 6x plus 9 minus 4, which is plus 5. And if you factorize that, 2 numbers. So you've got x and x. We're going to use kind of MAM if you want. 2 numbers. One is going to be a 5 and a 1. And which one, when you add them, so they're both negative. So -5 and -1. because -5 times -1 is +5, x squared minus 5 minus x, which is minus xx. And because the first one is 1, 0, then you can say the second one, x equals 5, to make this 0. So that would be another way of doing this if you didn't see that you had a symmetry here between the 1 to get to 5. So I don't know which is easiest. You can factorize if you want, or you can look at your graph. But both methods are accepted. Okay. So for your next homework, question 2, exercise 16b. So we're still on chapter 16. I was hoping we will touch a wee bit on chapter 17 tonight. So question 2. Okay, so basically what we've been asked here is we've got g of x, x plus p squared plus q, or sometimes you get a sad face with a minus x plus p. For each, identify the value of p and q. So it's just rewriting these using the turning point, which is what we've just been doing. So you've got 1, 2, 3, 4. So what we could do is we can quickly do this one together if you want. So you've got 7 and -4. So when x equals 7, I'm reaching -4. So you can just rewrite that as minus, because it's a sad face, x minus 7, because when x equals 7, I get -4, which is -4. That's it. That's all they've asked us to do. So you could do this exercise in less than 5 minutes by just using the turning points. Okay. So this time, in this part, we're looking at, again, similar quadratic function, but when a is negative. So let's have a look. So when a is negative, I just said that you've got what we call a sad face, but very similar to what we've been doing. So the curve, it's got the same axis of symmetry, x equals b. The turning point this time is not a minimum turning point, but a maximum turning point, and we cut the y-axis when x equals 0. Just the same rule, but this time we get a maximum turning point. So that the curve reaches its max. Okay. So complete the square for 4x minus x squared and then sketch the function. So this is the same as minus x squared plus 4x. So we're going to halve the 2. So we put a equal minus x squared plus 4x. So to make things easier, you can factorize this by putting minus outside. So take the minus outside by factorizing it. Now you've got negative 4x that you need to rewrite. Half, it's not half 6, it's half 4, and put into square brackets, so you get x minus 2 square, but then we need to compensate by adding 4. So that's us. We've completed the square. Now to sketch this function, x equal 2 is my axis of symmetry, and I get a maximum turning point of 2, 4. There's nothing to tidy up. So to sketch it, we said when x equals 2, I get a maximum turning point of 4. And when x equals 0, negative 2 squared is 4, time negative 1 minus 4 plus 4. So that passes through 0, 0. And if you wanted the other point here, you've got a pure symmetry here. So if it goes to 0, 2, it's going to go through 0, 4. Okay, so 2, 4, 0, 0 would be how you would sketch this. Okay, just so instead of a happy face, this time we've got a sad face. Similar to what we've just done, complete the square. So again, I'm going to rewrite this as minus x squared plus 6x plus 7. I'm going to put negative outside to make it easier. So negative x squared minus 6x. I'm going to halve the negative 6, which will become negative 3 minus x minus 3 squared. So because minus 3 squared gives me a plus 9, I need to compensate by taking away 9. Yeah. So it becomes plus 9, but because of the negative 1, negative 9 becomes plus 9. And then when you tidy up, you get minus x minus 3 squared plus 16. Okay. So let's see this one. Sketch the function negative x minus 3 squared plus 16. To sketch this, you would say axis of symmetry x equals 3. When x equals 3, I get a maximum turning point of 16. So 3, 16. It's the maximum turning point. A few things to fix here. Maximum. 316. Sad face. Let's see where we cut when x equals 0. Negative 3 squared as 9 minus 9 plus 16 becomes 7. So we cut it at 0, 7. And that's you. You would just draw that. Let's have a look at another one here. This time we've been given the function. We've been asked to rewrite it as a completed square. So you look when x equals 3, so x minus 3 squared plus 1 with a minus in front for the sad face. Same here. Start with a minus, x plus 4 square, and then minus 3. So we're not going to do this. Yeah, I could quickly go through this. So this is about revision. So basically here you would do x times x as your x squared minus 5x, and then 5 times x, that's 5x, negative 25. So x squared minus 5x plus 5x, those two cancel each other, and you should get a difference of 2 squares. You probably didn't need to do all this. You could have gone straight. This is a difference of 2 squares, x squared minus 25. Find the gradient. So you just say m equal negative 2. And where does it cut the y-axis? When x equals 0. So cuts it at 0, 6. Straight line. Cost before VAT. So here you've got a cost plus 10% of the cost equal 440. So that means 1.1x equal 440. That means x is 440 divided by 1.1. That is 400. So before that, the cost was 400. When you include VAT, which is 10% in this case here, you include £40. 10% is just divided by 10. And that's how you find that, by using algebra. Some people would say, oh, that's 110% of the price. Okay. So let's have a look. Very similar to what we've done so far. Graph of a quadratic function. We said happy face when A positive. This time, they are trying to get us to find the minimum turning points for this case and what we call the two roots when y equals 0. So when we have negative, we've got maximum turning points, still two roots. But this time we've got parabolas. So we've done this one, y equal x squared. That was the first one we did. So if x equal -3, this is how you would draw a graph. You would put a few points and then you would connect them. So -3 times -3 give me 9. So you can, it's just a way for you to have an idea how you would sketch it, for example. At 0, we've got 0, 0. And then when we've got 2, it goes to 4. And then when you get 3, it goes to 9. So once you've got a few points, you just connect them together and you draw the line. That line doesn't need to stop here. You can still go up if you want to. Okay. That's how you would draw this graph. And you've got here what we call the axis of symmetry, x equals 0. Now, if you are trying to draw x squared minus 4, same method. You just put a few points. So when x equals -3, -3 is 9. 9 minus 4 is 5. So that's that point there. -2 give me 0. 0 gives me -4. 2 will give me 0 again. And the last one, 3, should give me 5 because we've got a parabola. And then you draw your graph again. This time we've got x squared plus x minus 6. Let's put a few points. -4 squared, 16. 16 plus 4, 20. 16 minus 4 is 12. 12 minus 6 is 6. Put the first point, -2. Second point, when you've got 0, it's -6. That's a turning point. No, it's not a turning point. It's what we call the intercept on the y-axis here. 2 0. And then 3, 6. Okay, so we've got a symmetry here. Oh no. So, as you can see here, when you look at this, you've got that point here, 4 units, 3 units. So the turning point should appear here when you've got negative a half. Let's see what it looks like. You can see that it's getting lower than there. So you've got a minimum turning point because you've got a happy face. Okay, so sometime we can be asked to sketch a graph x minus 2 times x minus 4 that way. So the first thing we do is we need to find the roots, which is where we cut the x-axis. So when y equals 0, you either get x equal 2 or x equal 4. Then you write them down. So 2, 0, and 4, 0. The next section is to find the intercept for y. So y-intercept is when x equals 0. So you've got to write down when x equals 0, y equals 8. So that's your second point. So you've got this called the x-intercepts or the roots. This the y-intercept. Now the turning point is between root 1 and root 2, because we've noticed that we've got a line of symmetry. So what you do is you do root 1 plus root 2 and then you half it, and that should give you the turning point. So 2 plus 4 is 6. 6 divided by 2 is 3. And now when x equals 3, you sub that into x minus 2 times x minus 4, and you've got y equal negative 1. And the last point is this one, the coordinate of your turning point. So this is not in the completing the square form, but this is given as a factor of x minus 2 times x minus 4, for example. And this is how you would sketch your parabola in this case here, by finding out all these points. Okay. So let's see what it looks like. We've got the roots 2, 0, 4, 0, turning points 3, negative 1, and the y-intercept 0, 8. You put all those points and you join the parabola lines there. Okay. Now for your last homework, this is us touching now chapter 17. So question 1, page 163. We're going to do one example for that, and then that'll be us for the day. I think we've looked at quite a few parabolas. Okay. So quite a few homework. This should be, some of them are quite quick to do. A lot of sketching. But I can tell that it's been a long night. So hopefully next week we'll be concluding all the quadratics. So let's have a look. So we've been asked to make neat sketches. So just using what we've just done there. So let's say we're going to do E together. So this is how I would do E. I would find the roots first. So you would just write roots. So there should be 2 of them. when x equals 4, 0, and the other one x equals -6, 0. So that's the roots. Next thing, we can look for the y-intercept. That happens when x equals 0. So 0 minus 4 is -4, 0 plus 6, so -24. Okay. So axis of symmetry, we said we've got √1 minus plus √2 divided by 2. So axis of symmetry. They start to get very slow. So we've got symmetry. You've got at 4 minus 6 divided by 2. That is -2 divided by 2, which is just -1. So x equal -1 is our axis of symmetry. Roots, intercept. The only thing left is for us to find the turning point. Because we've got x squared, it's a minimum turning point. And that happened so what we've got here is x squared minus 4x minus 24. So for the turning points, so the coordinate is we find x equal 1, because that's the axis of symmetry. So when x equal 1, you've got 1 minus 4 times 1 plus 6. So 7 times -3, that is -21. So I've got a turning point of 1, -21. So we've got 1
6 times -4, sorry. Is it?
negative, yeah, so 1 minus 4, sorry, 18, 20. 6 plus 1 is 7, yeah? You're happy with that? And
Yeah,
1
yeah.
minus 4 is -3. So -3 times 7 is -21. And that's my minimum turning point. So I've got 1, 2, 3, 4 points, and that should be enough to sketch it. Okay? So quite a few steps to go through. And then to sketch it, you would just sketch. When this happens, you go, okay, I've got this here. I'm going to put first point here, we said was -6, 0. And on that side, I've got a 4, 0. So try to keep a bit of scale in there. And then we said that -1 was the line of symmetry. and it goes down to, sorry, x equal 1. That should have been x equal, symmetry is -1. I made a mistake here. Oops. Oh no. I'll tidy that up, but so it was -1. Can I do undo? Not sure, can I? This is going to be a nightmare. Anyway, so it should have been x equal -1. Axis of symmetry, x equal -1. Because the roots were -6, 0, and 4, 0. And when x equal -1, I've got -5 times 5 equal -25. So the minimum turning point should have been -1 -25. And this is what I was telling you when I was drawing the graph. Did you notice I said it's good to kind of have a way for you to see roughly that you've got something to scale? Because when I tried to put x equal 1, I noticed straight away that wouldn't have been the axis of symmetry. It should have been x equal -1. Okay. And what did we say? We had intercept when x equals 0. So intercept, what was the x equals 0? We said we had -24, isn't it? Yeah. So if you were to draw this graph, you would start -6 here, and you would have 4 here, and the axis of symmetry -1, and that would go right down to our turning point -24, sorry, -25. So 0 here, so -1, -25. And 0, -24 here. So I've got enough points to draw my graph. So the graph would go like that, back up, right through 4, and then come back down. Oops. So my pen is not working properly, you can tell. So it's all wonky, but it should have been a proper parabola like this. If I use my pad, it should have gone like this and gone through the 4 here. Okay. So you can have a bit of fun with these. But this is how you would draw.
I think your pad's done for the day, Adrian.
Yeah, you can tell that I can hear my laptop fans.
Yeah, it's like that. No more. Enough.
Enough is enough, yeah. Okay. So I've given you some grids anyway, so we can work with that next week. All right. And we'll call it a day.
Okay, thank you.
All right, so yeah, a lot of quadratics there for the day. So it's just a bit of
We'll see you
practice.
Yeah.
Yeah. See you
next week.
next week. Yeah.
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 We're nearly at the end of Unit 2, essentially, aren't we? We're just kind of getting